Right, welcome everyone. I think we're live here, so we'll wait a few minutes for people to, virtually file in, and then we'll kick off the talk.
Hello, Kush.
Hey,
Welcome.
Phoebe.
Thank you so much for joining us today.
Yep, it's my pleasure.
You're joining straight from IBM?
Yeah, I'm in the lab right now. Yep.
Great. Caroline, I let you lead this. How do you want to do it?
Yep, yeah, I'll be introducing Kush, and I'll do the moderation of the Q&A. Okay, so we're a few minutes in. I think we're good to start, Kush, if you're ready. Okay, cool. So it's my pleasure today to introduce Dr. Kush Varshney, joining us here from IBM. I will read an abridged bio of him and his many achievements. So if something didn't make the cut, I apologize, Kush. There was too many things to include. So Dr. Kush Varshney is a distinguished research scientist and senior manager at IBM Research, T.J. Watson Research Center, where he leads the Trustworthy Machine Intelligence Department and the IBM Science for Social Good initiative. He applies data science and predictive analytics to human capital management, healthcare, olfaction, computational creativity, public affairs, international development, and algorithmic fairness. He and his team has created several well-known open source toolkits, including AI Fairness 360, AI Explainability 360, Uncertainty Quantification 360, and AI Fact Sheet 360, which hopefully many of us here in our webinar has used before and are familiar with. He conducts academic research on the theory and methods of trustworthy machine learning and has independently published a book entitled Trustworthy Machine Learning, which is available for free online or very cheap for paperback edition. I definitely recommend looking up his book and reading it. And he's additionally a senior member of IEEE. So with that, welcome, Chris. We're so happy to have you and really looking forward to hearing your thoughts today.
Yep. Thanks, Caroline, and thanks everyone for joining. And yep. So let's get into it. So let me share my screen and then go from there. All right, so yeah, the title of the talk is Carative Approach to AI Governance. If you haven't heard the word carative before, that's okay, because almost no one has, but I'll explain what it is as we go through, right? All right, so let me begin with a positionality statement. So if you haven't heard what this is before, this is actually fairly common in other fields, not necessarily in applied math or engineering or these sort of things, but it's basically telling something about where the speaker or the author is coming from, because it kind of explains their own sort of biases or other things that that might be relevant, right? So the pictures, the left two pictures that you see, they're related to one of my great grandfathers and grandfather. So both of them used kind of technology and advanced sort of engineering and training to make social impact. So my great grandfather was the first person from India to study at MIT, and he studied glassmaking, and then went back to India and set up this factory, which was the Basel Fund Glassworks, and it kind of showed the British that India could be like industrial on its own, and fought for kind of independence for India through that, and educated a lot of people in glassmaking technology and so forth. And then one of my grandfathers, he studied control theory and other related sort of things at the University of Illinois, and then went back to India as well, and uh, did a lot on kind of using these sort of technologies for agriculture, and similarly, I mean, showing how these technologies can make India more kind of self-sufficient and kind of a socially uplifting way, and so forth. So it's kind of been in my family history to use technology in these ways, and uh, for my own sort of background, it started kind of doing more signal processing sort of stuff, and for the last 13 and a half, close to 14 years, I've been working at IBM Research, doing mostly machine learning and AI stuff. So that's kind of where I'm coming from, and the view that I kind of take on things is as kind of an insider, someone who's inside a company trying to do things that improve the world, improve situations in that way. And this is kind of an analogy to an approach like Henry Heinz used to have with processed food. So this processed food was kind of a new technology at the time that it was created in the late 1800s, and people weren't particularly trusting of it. So Heinz did a lot on making sure there's no adulterated ingredients, having clear glass containers for his ketchup, just like we have explainable models, offering free factory tours, doing a lot on tamper-resistant packaging. I mean, all sorts of things, and because he wanted to make the technology better, and I mean, overall in a good shape, which is. And there's another way to approach it. You can be kind of on the outside, an activist, muckraker of sorts, trying to expose the ills and kind of do things that way. But I kind of take the insider sort of view, and kind of doing small things to improve. Right? So now coming into the actual topic, right? So I don't have to kind of say this to anyone, but AI is now powering many critical workflows, and trust is essential towards that. So there's a few different development life cycles that we have seen and are now starting to see. So that includes kind of more data mining, data science, sort of traditional machine learning workflows. There's now the foundation models for generative AI that I'm sure everyone has played around with and is maybe doing research on. And even in kind of scientific machine learning for surrogate modeling. So these are all kind of different approaches, different styles of how machine learning happens. So they all have a different picture of what's going on. I'm not going to dwell on this here just in the interest of time, but there's a particular life cycle with kind of data mining, which is kind of this picture I have is similar to what's called CRISP DM, which is a standard for different stages. So starting with a problem, working with data, then doing modeling, evaluation, and then deployment and monitoring. There's also now this emerging new life cycle around foundation models where you don't start with the problem. You're just scraping data, doing a self-supervised representation learning to get to a foundation model, a base model, and then figuring out what to do with it, and having a sequence of alignment sort of steps, adding on some safeguarding, and then putting it into an application. And in scientific sort of work, it kind of matches up with the scientific method. So having kind of a hypothesis, doing some conceptual theory stuff, developing a computer simulation, then validating it, having a machine learning model that's acting as a surrogate for the very high computationally costly simulator, and then actually running experiments, and then continuing on and finishing up the scientific method. So with all of these, the question comes up, do we have governance associated with them? And the word governance is a bit of a strange word. And to get the point across, let's talk about what a governor is. So this is looking back again, back in the 1800s and stuff, when there were steam engines and so forth. A governor was a device to measure and regulate a machine. You could also call it a controller. Okay? So governance then is the act or process of overseeing the control and direction of something. And when we talk about AI governance, there's lots of different kind of definitions floating around. They'll usually refer to some sort of responsible or trustworthy AI, some laws and regulations. They could be philosophical in some sense, right? But let's come back to my sort of engineering roots and look at what would we mean by governance. First of all, just in general in a typical control system, and then we'll map this to what we mean when we talk about AI, right? So this is a very standard picture. So think about, let's say, a thermostat in your house. So you guys are in California, so I can't use the example of a furnace turning on, but in my house here in New York, we've started turning the furnace on, right? So there's a reference signal. So this is the temperature that we want to set, that we want our house to be, whatever, 68 degrees or 70 degrees or whatever. The thermostat is the controller. It'll trigger the furnace to turn on. Then there's a sensor that'll say, I mean, is the temperature below the temperature that we set? And if it is, then that error is then fed back into the controller, and it'll keep the thermostat on until the temperature is met, right? So now, if we look at this in terms of with these data mining like workflows, the same picture kind of applies, right? So instead of our setting of 68 degrees, we have some values, right? So this is what is serving as our reference. We have data scientists who are acting as the controller, and they're taking on the process of modeling to develop a machine learning model. And then that machine learning model is tested, and it produces some facts, some quantitative and qualitative information that we can compare to our values and see if there's any misalignment. And if there is, that means the model isn't good enough and we need to keep working on it. And if it is, great. So we have a model that we can deploy. And there's this kind of duality between what's valued and what's measured. So whatever we think are our values for a machine learning system, that's where we should be looking to see if we actually are doing the right thing or not. Okay. So what are these values, all right? So values actually start even earlier. So they start with principles. So these would be kind of overarching sort of frameworks that are acting as the guiding light for what we want to happen, right? And then we go through a process of value elicitation that leads us to the actual values, and then the pictures, as I said before. Okay? So in the rest of the talk, what I'm going to do is go through and describe a few of these different parts. So what are principles, value elicitation, testing, and facts, and then I'll come to kind of giving an example of some things, talking about this carative sort of point and so forth. And then at the end, I'll briefly touch on foundation models as well. Okay. So there's been research looking at what are kind of different AI ethics principles, and they've been coming out of different organizations over the last several years, including from companies, from governments, from civil society, and so forth. Most of them happen to have been coming out of economically developed countries and also rooted in some sorts of Western philosophy. Which might or might not be a good thing, but it is the situation. And there's been analysis showing there's kind of 5 common core strain principles that emerge when you analyze a large set of these ethics principles. So one of them is privacy, another is fairness and justice, a third is safety and reliability, A fourth is transparency, which in the terminology of this work includes explainability of models, but also kind of overall transparency of the life cycles. And then there's social responsibility and beneficence. And when we look at this across those different sectors, there are some differences that emerge. So governments are often emphasizing economic growth and employment. They also might refer to or allude to a kind of an arms race among countries. So let's say between the US and China or things like that. Okay. Private industry, so companies usually just stick to those common principles. And there's sometimes an accusation that companies are putting these out as kind of an ethics washing sort of thing. So they're just doing it so that they're kind of shielded from criticism and so forth, right? And civil society is interesting. So if we start thinking about why do like nonprofits and NGOs and civil society exist, it's because there's something that government and private industry isn't taking care of, right? So civil society kind of exists as a criticism to government and industries. So a lot of the ethics principles go beyond the five core sort of principles and kind of emphasize shifting power to the most vulnerable and are often kind of stated in terms of critical theory. So these are kind of the differences, right? So once we have those principles, then the next sort of questions are what are like actual values that we can actually implement or look at from the lens of machine learning. Okay. All right. So when we think of value elicitation, we want to use those principles as a starting point and then specify the desired behavior of a system. So principles are, as I said, the starting point. Then there's the context of the actual application of the industry you're in, of the social norms of the end users, etc. And all of that leads to the values, right? So there's, in my mind, kind of four levels of elicitation. The first question is, should you even work on the problem? Second is, which pillars of trustworthiness are of concern for me? And I'll explain what that is. What are actual appropriate quantitative metrics for those pillars? And then what are the acceptable ranges of the quantitative values of those metrics? Okay. So many times we don't even ask ourselves, should I even be working on a problem? And I think we should, right? So there's many reasons that one might think not to work on a problem at all. There's no right or wrong answer on this. These are just things to think about, okay? So maybe if a system is leading to disinformation and subverting the truth, it could be a reason not to work on a problem, but it might not be a barrier as well. If a system leads to addiction or engaging users beyond what's good for them, if it leads to inequities of various sorts, if it's amplifying social biases, is it repressing dissent in some ways? Is it causing people to lose control over their data and also the value of that data? Is it doing things that users don't know about? Is it enabling bullying or fraud or theft or other things like that? So these could be things that cause you to think twice, but again, there's no right or wrong answer to this. Right? So how do you reason about that, right? So there's this technology called CP nets. So the CP stands for two different things. Stands for conditional preference. It can also stand for ceteris paribus, which is the Latin term for leaving all other things equal, what do you do? So what these CP nets are, it's similar in form. It is a graphical model. It's similar to like a Bayesian network, if people are familiar with that. So you have nodes, which are the sort of concerns, and then there's some other node which is kind of conditionally dependent on those other things, right? So for us, the question is, do we work on a problem or not? And in addition to the graph, there's what are called conditional preference tables. So this weird looking inequality sort of operator is a preference. Do I prefer to work on the problem? If again, this is just one example, there's no right or wrong, but let's say for me, if I say that if all of the items are yes, then I don't work on it. The only sort of case where I would work on the problem is if all of the different items are no. So that would be how this graph comes about. This particular one is very straightforward. You don't need to do anything fancy to figure it out, but this technology is useful when it's more complicated and when there's kind of other sort of considerations, and I'll get to an example of that in a second, right? So coming to that second level, so there's the question of which pillars of trustworthiness are of concern, assuming that the problem should be worked on. So some of the potential things to look at are fairness, explainability, uncertainty quantification, distributional robustness, adversarial robustness, and privacy. So in a talk like this, I'm kind of assuming that you guys have some sense of what these are. It would be a completely different talk if I kind of went through what they are, but just if you're not familiar, then they kind of are all different sort of notions that are important when you're potentially looking at kind of high consequence sort of applications. Okay. So what would be like you could ask someone just directly, I mean, do you care about explainability? And sometimes it's hard for end users, for subject matter experts to just tell you, like, yes, I care about explainability or not. So it's often easier to ask them questions that are more in the context of what they're doing. As an example, these are some questions that people are more able to answer than what just directly about these different pillars, right? So one would be, is there some systematic disadvantage given to certain groups or individuals? Uh, is there a human decision maker that's being supported? Will there be external auditors involved? Can the users challenge the decision that they receive? Will the model be retrained frequently? Is the data about people? And if so, does it include sensitive information about those people? What sort of security sort of things are in place in the system, right? So when we look through those, again, we can look at this through CP nets. So this is another sort of graph that I've drawn. So if you look at fairness, it's not really affected so much by like security things or retraining sort of things, but what it is affected by is whether there's the possibility of systematic disadvantage and whether the data is about people or not. Like distributional robustness only is affected by whether there's retraining frequently, but explainability has multiple sort of inputs. So whether there's a human decision maker, a regulator, and the chance for recourse. And associated with these are these preference tables. And so, for example, in distributional robustness, the only thing that matters is if there's not going to be frequent retraining, then having robustness is a high priority. And if there will be frequent retraining, we don't need that sort of robustness, right? And we can go through this with fairness. It actually doesn't matter if it's sensitive personal information or not. So that's why there's kind of two reasons that are equivalent, where there is the possibility of systematic disadvantage and there's data about people, and both lead to high priority. So there's ways to use these to help reason. Okay. Then moving on to the third question, the third level that we had. So it was what are appropriate metrics for the different pillars of trustworthiness? And here, it's not so much a question of kind of like what would be a preferred sort of thing in the sense of like a personal preference, but it's more about the kind of what sort of biases and what sort of worldview do you have? And specifically on fairness metrics, there's a question of whether you believe there is or is not social bias in the system. And that leads to a particular choice among possible fairness metrics. Okay, so there's three main categories of fairness metrics. They go by the names statistical parity difference, average odds difference, and average predictive value difference. And the top one, statistical parity difference, makes sense when there is social bias, and the others when there is not. So these sort of ways of thinking help you determine what would be the right metrics for your use case. Okay. Um, and then when we get to the last level, so this is about what are the acceptable actual values. So here, it's always easy to say, I want the best of everything, right? I want perfect accuracy, perfect fairness, perfect empirical robustness, and et cetera, right? But we know, I mean, in real systems, there are trade-offs. There's some things are maybe not trade-offs, but many times there are trade-offs. So what we want to focus on are actually feasible sort of options in this elicitation. So with this, we do have to worry about the interactions among these different pillars and only choose things that are in our feasible set. One thing that I have been looking at in the last few years, but haven't had a chance to spend as much time as I would like, is actually we're characterizing these feasible regions in terms of information theoretic quantities, and that would help us actually know what the feasible set is. And then you actually have to ask, right? So this can be done in different ways. It can be done through kind of visualization-based approaches where you kind of plot out different dimensions and the values of the quantitative metrics and so forth, and see what are all of the different possibilities, and then ask people to state their preferences through that. It can be done through kind of binary choice sort of setting. So you present a couple of scenarios and ask which one would you prefer. And when it's kind of couched in the language of a particular application, so here like, receiving or not receiving a fellowship, then people are more able to kind of think through what it would mean to them. And having small numbers of items is also easier to deal with, right? So that takes us through kind of these four levels. But a point that I want to make is that when you're eliciting from one person, that's fine, but often we want to have a group of stakeholders, including affected users from vulnerable communities, to provide their thoughts on what should be done. And there are existing aggregation methods, both for CP-nets as well as for pairwise comparisons. But in both cases, eventually these aggregation methods boil down to voting. And this could be a problem if there's minority voices who are raising important points, but they just get drowned out because what we're looking at is a voting scheme. So there might be other ways to think about this. So that could include participatory design sessions and other sort of stuff. Okay. All right, so that takes us kind of into beyond the principles and the value elicitation. So we're at some values. So we've gotten to what are dimensions we care about, what are the actual ranges of those quantitative things. And so then that provides a recipe for data scientists. This is what we're aiming for. And if we're not, then we have to do something more. And so trying to know whether we are or we aren't meeting our values and goals requires testing. So machine learning testing is a bit different than testing of other stuff. So we don't just have a thermometer like my thermostat example, or even in software testing of other kinds, you often know like what the right answer is supposed to be. Like we know 2 + 2 is supposed to equal 4. And you can test software that way. But with machine learning, the whole point is that we're trying to generalize to new unseen samples. And so we don't actually know what the right answer is supposed to be for a given input. So that's what's known as the oracle problem. So there's kind of approaches, one of which is called metamorphic relations. So here you're not using one input, but you're using more than one input. And you don't know what the right answer is supposed to be for a given input, but you can know in advance that maybe the answer should be the same for two different inputs, right? So that could be like in the picture with like different sort of transformations of an input. It could also be like in a fairness setting, change, let's say, men to women or something like that. And that would test for counterfactual fairness sort of thing. So there's kind of ways that we can do that sort of testing and so forth. Another thing that is also true is that it's hard sometimes to generate test cases. It can be done through adversarial examples, so kind of pushing the system to its limits in certain ways, but kind of having good coverage is an open problem. And this is exacerbated now with the foundation models as well, because they kind of have some emergent behaviors going on where we don't even know all of the things that we should be testing for. Another thing that I kind of always recommend is having uncertainty quantification with this testing, and not just measuring accuracy, but all these different trust-related metrics. And the uncertainty is a useful sort of thing because it leads to kind of an intellectual humility of sorts. So you're presenting your own limitations. You're aware that not everything will be kind of as reported and so forth. So that is kind of the testing. Once you have it, it needs to be reported. So one thing we've been working on for a while is what we call fact sheets. Other groups will use terms like model cards and so forth. But one thing that we find very important with these fact sheets is that it's actually something helpful in the life cycle itself. It's not just a transparent documentation and reporting thing, but something to help you along the way as you're developing these systems. So you're kind of collecting different qualitative and quantitative facts, both from the system as well as from the people involved. And then they can be rendered out in different ways depending on the needs of the end consumer. So they could be very detailed for the data scientist. They could be kind of a certificate or some label for a regulator and so forth. So this is something that we've kind of been developing a lot of technologies on, and IBM even has a product for fact sheets these days. Right? So I took you through this entire sort of control theory view, but there was something that was quite missing from this entire discussion. So any sort of ventures into what that might be? So what I think was missing was this whole aspect of caring. So this is a picture from the Wall Street Journal, and it hasn't, I mean, certain issues with the fact that the doctor is a man and the nurse is a woman. But beyond that, what I wanted to point out is uh, look at the doctor. So the doctor is just looking at the chart, and he's kind of not even looking at the patient, kind of ignoring the patient in many ways, just focused on like whatever can be put into the chart, right? And the nurse is looking into the eyes of the patient and trying to do everything that she can to help the patient in a holistic sort of sense. And that's kind of exactly sort of what I want to emphasize, right? Just an interesting anecdote. So there's a person, Gene Watson, who has done a lot on the science and the theory of caring. And just to contrast Gene Watson with the IBM Watson, so like a very like mechanical sort of thing versus a caring sort of approach, right? So when I was doing all of this like discussion around control theory and pillars of trust and quantitative test results and all of that sort of stuff, it was all of what I would call a consequentialist flavor. So consequentialism is a type of philosophy that what matters is just the outcomes. So whatever I can observe in an outcomes in a chart, I mean, that's all I worry about, right? And this is also how AI ethics is typically framed. So there's variations. There might be like this other thing called deontology, which looks at quantitative things related to the actions rather than the outcomes. But in both cases, it's all about just looking at like what is happening in an abstract fashion, right? Just an interesting side note, we developed this system a few years ago that looked at AI ethics sort of things. And since we're still in the Halloween time frame, I can show you kind of what this thing does. So it's kind of this Pac-Man game. So we can kind of instruct the system to not eat the ghosts as kind of a moral behavior. And again, the point that I'm trying to make is that what we are instructing this thing on is something that you can specify so like abstractly that just don't eat the ghosts. It doesn't matter like what the context is or kind of what's going on and so forth. So that's what I think is the thing that's missing, right? And the other question that arises is this deontology consequentialism thing is very much in a Western philosophy sort of mode of things. But what that leads to is forgetting that there are other ethical approaches. And this paper by Birhan et al. Kind of says that the field would benefit from concrete use cases, from people's experiences, from approaches that are sensitive to power asymmetries and so forth, right? And that's what I'm going to kind of get to now, right? So one of the sort of scriptures in Hinduism is called the Bhagavad Gita, and the initial sort of reading of it is all about kind of doing actions without thinking about the results. So kind of not worrying about the fruits of your actions, so not having desires. And this is kind of an initial reading, but what others have further discussed is that there's kind of this second order understanding, which is kind of going beyond this deontology consequentialism sort of debate, right? And specifically, what is being talked about is this concept called Vishesh Dharma. And so the idea is that so this Bhagavad Gita is all about this prince who is about to go into battle, and the other side's army has a lot of his relatives in that army, and he's kind of saying like, should I actually partake in this war or not? And the instruction given to him is that there's a lot of specific duties that are just for that person for in the context based on kind of the skill, the family history, the reputation, the station in life, and so forth. So there's a lot of context that goes into the values that are not just the generic ones that we could apply more broadly, right? So there is no generalizable abstract law or duty for everyone. And this is a different sort of view on things where consequentialism, deontology, and so forth are aiming for a universal sort of ethics, right? So this is a form of kind of value pluralism. And this is exactly the sort of thing that we have to worry about when we're taking a carative approach. And I kind of forgot to mention, yeah, so Gene Watson is the person who came up with this term carative. So it's a contrast to curative. So it's not just curing, but caring holistically, right? So when we're doing AI, we should be starting with the real world problem as it's experienced by the most vulnerable. Listen to them, understand their values. That's the context. Meet them where they are and work towards a solution and go all the way to the end, not stop at, oh, I got an Europe's paper and that I'm done, right? I mean, it's doing everything involved to really work towards the solution and then conduct a qualitative assessment at the end as well. Okay? So let me give you an example of this just to make it concrete, and then we'll draw some generalizations and lessons from it as well, and then I'll come to the foundation models at the end, right? So this was a project I did a few years ago, I guess, yeah, several years ago now. It was a project with this organization named Simpa Networks, and they do something called pay-as-you-go solar power for villages in rural India. And a lot of villages in India are connected to the grid, but they don't receive power like 24 hours a day. So people who want to study at night or charge their phones or run their fans or whatever, watch TV and stuff, it would be good if they had some other power source when the grid power isn't coming. So they would want to install a solar panel on their roof, which would then power the things that they want, right? So at the time we did this, a lot of the people in some of these villages were using kerosene lamps, and they could for nighttime illumination, and they can afford the kerosene, and they can then, if they have these solar powers, instead of using the money for the kerosene, if they just funnel it towards paying for the solar panel, they would have, I mean, plenty of money to do so. It's just that solar panel is like a one-time capital investment, so you don't often just have all that money at the same time. So what Simpa Networks does is take a small down payment and allow people to repay over time. Okay. So what I was involved with was the sort of application processing. So Simpa doesn't want to approve people for these repayment plans if they're unlikely to repay, because then they'll have to go and repossess the system and stuff like that, right? So with that, the task was kind of a credit scoring sort of problem, but a little bit different. Okay. Oops, sorry. So yeah, there's the predicting repayment is the task, right? So when we started working with them, we learned that there were some folks on the engineering team of the company that wanted to throw in every single feature that they could, and this included the last name of the individual, which is highly correlated with the caste and religion of the person in this part of India, and so forth. So, by being fully invested into understanding the context and what's going on, we could suggest that maybe this is not something that you want to do. And we didn't, we did the bias mitigation and so forth as part of this. So there was a lot of learning where if you just take a bunch of columns and just apply your favorite method, you're going to miss out on the context. And that's exactly what, I mean, the truly caring and understanding what's going on will lead to. Okay. So we did, I mean, develop a model. It's not important what the AUC and other things were. This was a very challenging sort of problem, but some of the interesting things were also like, what are some of the features? And one thing that was a bit different than a normal credit scoring thing. So in this part of India, a lot of people, if they can afford it, will get these battery packs called inverters. And the more you, I mean, wealth that you have, I mean, the more that you can afford this inverter. But that was actually a negative factor towards repayment, because it wasn't actually like a wealth sort of question. It was, if they have these inverters, then they have this other power source. So then they don't need the solar panel, so they're less likely to repay for it. So all sorts of interesting sort of things. But at the end of the day, the result that matters is talking to the people who are actually the recipients of the system. So I did go to one of the villages and was able to, I mean, talk with some of the recipients, understand like what the system was used for in their context, how the application process went, and all of that is actually the qualitative results that do matter, right? So, kind of drawing from this, then the sort of higher level sort of lesson then is that there's this entire field called action research, which is a process where you kind of diagnose a problem, take actions, evaluate, and then this sort of stuff is the curative approach. You do kind of learn from it, and or sorry, you are kind of caring for people. You're going in depth, but then there's this fifth step in action research, which is generalizing the findings, right? And this is the research part, right? So this is what I would kind of advocate for. So it's not against the spirit of having like one's own duty in the sense that each case is different and so forth, because you do want to learn from the experiences that you go through with different patients, with different sort of settings, and then kind of generalize and so forth, right? So what we do want to do is learn to figure out best practices from working on real problems, use those learnings to then generalize and know, oh, these are good ways to approach using AI in kind of social good or whatever, I mean, sort of setting that you're in. So let me quickly just mention foundation models because I would be remiss if I didn't. So I think everyone is aware of ChatGPT and friends. So just one small point is that it's not just language. There's foundation models now for programming languages, for time series, for chemistry, and so forth, right? So when we talk about the trustworthiness, a lot of the risks are the same, but there are some new categories. So hallucination, lack of source attribution, stuff like that is one big category. Toxicity, bullying, gaslighting stuff is another sort of big category. And we've and others have, I mean, created full taxonomies of all of these different risks with foundation models. But the point that I want to end with is that this is just the starting point. And when we create these taxonomies, these common sort of risks and harms and so forth, it does miss this sort of curative approach, right? So as we've been talking with different companies, different industries and so forth, we are seeing that beyond these common sort of concerns, then there are specific laws, specific industry standards, specific social norms, corporate policies, etc., that are leading to behaviors and requirements that go beyond what we can include in a taxonomy. So just some examples. So a bank we're working with doesn't want their chatbot to mention any other bank, which is a reasonable thing, but it wouldn't appear in one of these common sort of taxonomies. Certain countries have specific laws, like in China, there's a law that says any generative content should embody the core socialist values. There will be different style guides that different organizations want, different corporate policies. Like in IBM, we have something called the Business Conduct Guidelines that we just actually this week fine-tuned a language model to obey the IBM Business Conduct Guidelines and so forth. So these are going to be unique things. And this relates to my earlier point, which is that when we think about these unique context-specific duties, that is this Vishesh term that I mentioned before. So that is just as important as these common sort of requirements, which is known as Sadharan dharma. So let me end there. So just to conclude, we can view AI governance as a control problem. It doesn't make sense without context, and maybe we've been blinded by the use of Western philosophy, which is almost always aiming for universality in the ethics. And so curative AI governance implies focusing on the entire development life cycle and making choices that are centering and listening to the most marginalized throughout. So let me end there. Last slide is let's just remember not to devalue caring work because that is so commonly done in our society. So let me end there. And yeah, this is the book that Caroline mentioned. So yeah, it's free PDF if anyone wants it. And yeah, so let me stop there and happy to take questions. Right?
Awesome. Thank you so much, Kush. What a great nuggets throughout. I definitely want to see a copy of your slides after to go through.
Sure, absolutely. Yeah, I'll send them over. Yep.
Yeah. So yeah, we do have some questions in the Q&A. I will encourage people to send in more questions as you have them. So our first question is from an anonymous attendee, someone with a little sky, I guess. They said, this is a great framework for which models to use. Do you take the same approach to assessing which data should be used or which data is ethical to source?
Yeah, I think that's a great question. Yeah, the framework specifically that I brought up with the 4 levels of questions do apply to kind of metrics that you can compute on models, but I think the same sort of questions do come up when thinking about data. Some things are more or less like knowable from data itself, but yeah, I think the same general concepts should apply. And yeah, like I was involved recently with IBM's own foundation model, which we released called Granite. And we did a lot of kind of data curation, data governance sort of stuff there. So yeah, it was thinking through a lot of the different risks and harms, putting in different controls for like copyrighted content or for profane stuff and so forth. So yeah, a lot of the same things do apply, I think.
Thank you. I have a question myself or Phoebe, go ahead. You have a question.
Go for it. I'll go after you, Caroline.
Okay, I wanted to ask how you were connected with the project in India, and how you found that opportunity.
Sure.
And do you have any advice for PhD students or early career researchers, right, wanting to make real world impact, and how do we find, collaborators and projects such as that?
Yeah, so that specific one was done through DataKind, which is a nonprofit which connects practicing data scientists to social change organizations. And yeah, I started that project. I think it's been a while now. I mean, it was back in 2014, but I mean, DataKind still exists and are doing a lot of things. Yeah, I mean, the whole AI for social good sort of space has evolved in the last 10 years for sure. But yeah, I mean, I think, and you guys are better, I mean, than anyone else. I mean, USC or I mean, you really, I mean, do think about like how to really work with partner organizations and do things in the right way. So I mean, I think working through, I mean, USC to begin with, I mean, I think is a great way to get connected with the organizations. But I mean, even after you leave USC, I think there's different organizations that can be matchmakers of certain sorts. Also, if you have any certain interests where I mean, kind of are looking to make a difference, then like just kind of be active and go for it. So, yeah, I don't think there's a precise formula, but I think there's a few options, and there's many organizations now that are hiring their own sort of like innovation teams as well. So like in the United Nations, they have a very strong sort of innovation set of activities across different directorates and so forth. And yeah, I think there's a few different ways.
Thank you. All right, Phoebe, do you want to go ahead?
Yeah, sure. So you mentioned LLMs in the end of your talk, and for me, fundamentally, the difference, at least for researchers in universities, maybe that's not true for your side, is that we cannot train LLMs, and so then how can you design LLMs that are going to align with human values, that are going to have those nice properties of fairness and robustness and whatnot? And even just fundamentally that you can do this because you're in industry, like
yeah, no, it's a great question, and even though I am in industry, we don't have as much horsepower as like an OpenAI or an Anthropic and so forth. So yes, we are, I mean, training some large models, like the Granite one that I mentioned is a 13 billion parameter model, and we're going to have some larger ones soon, but we're never going to be doing something like a trillion parameter model like what GPT-4 is rumored to be. So the way I think about it is like taking the perspective, I mean, of a university or any like in other company that's not like a tech company, right? So even like banks or like manufacturing companies or whoever else that IBM tends to work with, they aren't going to be in the business of training a base model from scratch. And so we really should kind of think of a separation between like model providers and model consumers. And one analogy that I've started using, I don't know if it's a perfect one or not, but when we think of children, right? So they first start to repeat words, then they'll follow instructions a little bit, like you tell them put a cup on the table, maybe like half the time they will, or something like that, and then they'll start chatting back and forth with you a little bit more. And it's at that point where like things become more subjective in the sense that introducing your culture, your values, your skills, and so forth. So to me, like model providers, up to the point of kind of instruction following and the ability to chat, that kind of alignment makes sense. But then once the model providers start then introducing their own sort of values and they kind of act like God in the sense that, oh, like this guardrail should be there or not, and so forth, that it becomes, I think, a little bit problematic. So one thing we're working on quite a bit is at the point that you do have a model which is able to follow instructions, then how to do more parameter efficient instruction tuning that will allow and empower, I mean, different organizations to bring their own values and so forth. So when I mentioned that we just finished training an IBM model or the model on the IBM Business Conduct Guidelines, that was for us to test it for ourselves that if you had some sort of policy document or some sort of set of principles and values, how could we, in a parameter efficient, low cost sort of way, improve the models to follow those specific like Vishesh sort of values and so forth. So that's exactly what we're trying to do. It doesn't solve the problem of not having computational resources to do full fine tuning and full like pre-training and so forth, but in my mind, I think kind of starting at that point and allowing for that value to be brought in is the right way to do it.
Got it, thanks.
Sure. Other
If there are no more
questions?
questions, I have one more, but then
Sure.
I'm going to make sure we have time to ask theirs.
Go ahead, Dee.
All right, actually, this one is a small one. Can you go to slide 51? There's something I didn't understand, which was your example where there was discrimination because some of the features were kind of predictive of race, was it something like that?
Yeah, this one. Yeah. So the data set actually had the surname of the individual who was applying for the solar panel system. And it turns out that in this part of India, that the surname, if you just read it, you have a pretty good sense of the caste and the religion of the individual. So the engineers of Simpa Networks, who don't really think about ethics and other stuff, they were like, yeah, I mean, let's throw that in as well. It actually increased the accuracy by like a percent or two. And so the question arose like if we didn't really like delve deep into like what was going on, then yeah, it would have led to kind of unfairness issues. And so
I guess my question is, I didn't really understand why this is an issue. It may sound silly, but so if still we show that by including surname or even caste and religion themselves, we can increase accuracy, but then also have equal rates of mistakes for different faiths and people from different religions. Wouldn't that be okay? So I don't understand what is fundamentally wrong with including this.
That's right. Yeah, no, that you're absolutely right in that sense. So including features by itself is not the problem. So maybe, yeah, I could have like in a more detailed sort of thing, I could have gone through exactly what the issue was. But yeah, no, I mean, in general, for fairness stuff, actually including having those variables, the protected attributes is useful because then it allows you to mitigate biases in a better way and test for them. So in particular, I mean, when you're saying about the false negative rates and false positive rates, so if I go back to this slide that I had here, Right. So really, in this case, what we should be using is average odds difference. So the reason for that is that in this case, there is no social bias in the measurement itself. Everyone's filling out the same application form, and the features inherently don't include a kind of a social bias. And the label itself is assistive because you are receiving something. You're receiving the solar panel, right? So for those cases, this average odds difference would be the right sort of metric to look at. If including those features of caste and religion and so forth allow you to improve the average odds difference, you should definitely include them. Yep.
Got it. Thanks.
Yep. Yeah, it was just kind of glossing it over. So yeah, I mean,
I thought maybe I didn't understand something.
yeah.
Perfect.
Yep. Yep.
All right, well, I think we're at time here. I don't want to keep you too long, Kush, but thank you so much for your talk. This is really awesome.
Thank
Sure.
you so much, Kush. Thank
Yep.
you.
Yep, my pleasure. And yeah, I'll send over the slides later, Caroline. All right.
Yes, please do.
Okay.
Thank
All
you
right.
so much.
Thank
Great.
you so much.
Thank you.
Thanks.
Bye, everyone.
Bye.